We are from Group 1-2 and will present on zero waste for Malaysian palm oil industry. And Deborah Chiu and I'll present on the introduction. Do you know that Malaysia is actually the second largest palm oil producer and exporter? In 2020, Malaysia's contribution to the global palm oil production is around 25.8%, in which it produced around 20 million tons of palm oil. Not only that, Malaysia's contribution to the global palm oil exports is around 34.3%, in which it exports around 80 million tons of the palm oil. The utilization of this high-quality palm oil generated can be seen in different industries, including both food and non-food applications. The common usage of palm oil is tabulated here. Despite the benefits that I mentioned before, we can see that there are a large amount of waste produced from the palm oil industry, and the palm oil milk effluent is the largest byproduct. Now I'll move on to talk about the problem statement and objective. The first problem is that the disposal of the palm oil waste will cause environmental pollution. I've included two examples here and can see that the disposal of the palm oil milk effluent and the anti-fruit branch will cause the global warming and water pollution. The second problem is that the waste management and control system in Malaysia is still lagging behind. The statistics show that only 20% of the palm oil plants in Malaysia have installed the biogas capture systems, and you can see that most of the palm oil waste in Malaysia is not fully utilized. Therefore, we need to develop and implement the flexible technologies and strategies to approach the zero waste goal so that we can achieve sustainable development in the palm oil industry. In line with the problem statement that I mentioned before, we come with 4 objectives for our project.
Hi, I'm Muaz and I will be explaining about the process control and justification. From our research, we managed to find the integrated zero waste palm oil processing strategy made by Universiti Kebangsaan Malaysia and also Yayasan Saibdari. The strategy divided into 7 trusts, where each trust focusing different aspects of treating the POM and EFB. However, for our project, we are focusing on the trust 3B utilize the POM and EFB hydrolysis for biohydrogen production using the two-stage anaerobic sequencing batch reactor or ASBR. At the ASBR, we are converting the POM and EFB into the hydrogen as a source of energy, and the first reactor operates at thermophilic temperature, which is 55 degrees Celsius, and the second one operates at mesophilic temperature, which is 37 degrees Celsius. According to our research, the highest yield of H2 was obtained at a thermophilic condition with an initial pH of 5.5. To maintain the pH level in the ASBR, use the pH control by determining the pH level and then reacting with the sodium hydroxide or HCl in order to maintaining the 5.5 level for the pH value. Thus, we can have the highest yield of H2.
Hi, my name is Ivy, and now I will explain about the challenges of process control. The first challenge of process control is the high operating cost. To achieve maximum yield of hydrogen, the set point of pH value are set at 5.5. The on-off bang-bang control used will lead to the hunting of the relay around the set point so that the system is always under optimum pH conditions. When the pH value drops below 5.5, the injection of the sodium hydroxide starts until it goes back to the optimum pH value and stop. However, the mixing in the tank still operating and will once again bring the pH value below or above the set point, which will start the injection again. This will start the circle all over again and consume high amount of expensive chemical. Thus, the operating cost for the pH control system become high. The next challenge of the process control is the non-linearly nature of pH. Unlike many other control variable in process plant, pH control system behave relatively non-linear. It is hard to estimate the amount of acid or bases needed to adjust the pH to desired value. From the graph shown, it can observe that each 10 ml of base added increased the pH inconsistently. For the first 10 ml added, the pH increased by 1 pH point. Meanwhile, for the third 10 mm of best added, the pH increased drastically from 4 pH point to 11. Thus, it is difficult to monitor the amount of acid or base needed to get the optimum condition, as there is no fixed pattern acid for the pH control system.
Next, for this chapter 3.2, we will discuss about recommendations for process control of palm oil industry. There are 3 recommendations suggested for this process control. The first one is enhancement of process by adding butyl ferrylate into the process. It is believed that addition of butyl ferrylate at 600 ppm to use palm oil milk effluent reduce hydroperoxide generation by 80%, and the output unimportant gases could be lowered. The nitrogen dioxide gas could be reduced about 4.7%, carbon monoxide of 27.8%, carbon dioxide of 8.3%, and unburnt hydrocarbons of 5.7%. Next, we can culture the microalgae as secondary treatment of pomade to reduce the cost. The microalgae is not only as one of step for treatment, but by using mechanical press machine combined with solvent extraction, it can also produce biodiesel as a product. Last but not least, palm oil fronds also can be utilized after it was managed properly by drying with solar drying method. Proper drying of fronds could be used for other purposes such as feeding livestock and handcraft making. This could increase companies' incomes and cover the high-cost process production.
Hi, my name is Nur Zafira, and I will present the conclusion of this project. To conclude, the palm oil industry has been selected as the chemical industry in Malaysia using a process control system. Our project's problem statement is the disposal of waste in the oil palm industry, which has affected water and air quality. Then the integrated waste process for the oil palm industry, made by UKM and YSD, has been chosen as a zero waste management approach. Finally, the challenges faced are due to the high operating costs and non-linear behavior of pH. To overcome this problem, the application of butyl ferrolate and the cultivation of microalgae is suggested. Therefore, it is essential to look into the zero waste management approach that could lead to a better environment.